Let's have a look at the derivatives of x equals f as a function of y. All right, there's a general rule. It turns out that dy dx is equal to the reciprocal of dx dy, so long as dx dy does not equal 0. This handy little trick allows us to carry out a lot of differentiation quite simply. So as an example, let's say we're given x equals y cubed minus y squared. So here we go, x equals a function of y. Find its gradient at y equals 5. And also at x equals 2. X equals 0, sorry, x equals 0. Part 2, I meant by that. All right, so for the first part, dx dy, I'll just differentiate that 3y squared minus 2y, 3y squared minus 2y. And then dy dx is 1 over the reciprocal of dx dy, so that's 1 over 3y squared minus 2y. And so at y equals 5, dy dx is 1 over 3 times 5 squared minus 2 times 5. That gives us 1 over 65. Okay, good. Okay, but how about if we wanted to know what is the gradient at x equals 0? All right, well, we could do that too. At x equals 0, we have 0 is equal to y cubed minus y squared. Well, let's factorize that. We've got y squared outside of y minus 1. Now, by the null factor law, that tells us that y squared is equal to 0, or y minus 1 is equal to 0. Okay, well, y squared equals 0 means y is 0. That implies y is 0, and y minus 1 equals 0 means that y equals 1. So there's two cases to consider here. Y is 0 and y is 1. All right, well, we're interested in the point x equals 0. So the first set of pair of coordinates, x, y is 0, 0. X is 0, y is 0. And the second set of coordinates, x is 0 again still, and y is 1 in this case. So here's our two coordinates. Now, at y equals 0, dy dx is 1 over 0 minus 0, okay, which is undefined. Okay, so at y equals 0, dy dx doesn't exist. At y equals 1 though, dy dx is, so the gradient now of this curve, dy dx, is 1 on 3 times 1 squared minus 2 times 1. Well, that's 3 minus 2 is 1, that's 1 over 1 is 1. So at y equals 1, we have dy dx is equal to 1. Okay. Let's have a look at another example here. In example 2, given x equals 5y to the power of 4 minus 2y cubed plus y, find dy dx. Well, dy dx is the reciprocal of dx dy. In this case, we can find dx dy is 20y cubed minus 6y squared plus 1. Okay, and so that implies that dy dx is just 1 over 20 times y cubed minus 6y squared plus 1. So we didn't really need to solve this in terms of x. We didn't need to solve for y in terms of x. We can just go ahead and differentiate and then take the reciprocal. So it's a convenient technique that helps us all round. Okay, and we can still find the gradient of the function x equals y cubed minus y squared as we did up here, and we can find it at y equals 0, or we could find it at x equals 0 or y equals 5. Okay. So, but the point is, this handy technique dy dx, we can take the reciprocal, we can find dx dy, take the reciprocal, and that gives us dy dx without having to solve. Okay.